Hey everyone, my name is Phuong. I'm currently a student at Brown University. I'm just in Portland for the summer. I'm also a consultant at AppNexus. And today I just want to talk to you about like a project I did in one of my class, just predicting click performance for Facebook posts using like a Bayesian linear regression model. So, so yeah, the goal of the model is to predict how many clicks are generated by like an ad post, right? That's something that advertisers really care about, how well their ads perform. And the performance metric here I'm using is clicks per 1,000 impressions. So like of 1,000 times the ad is posted, how many times it's clicked. Just a little about the data. Essentially, Facebook releases data in 2017 for one of their page. And it describes like the category of the ad, the type of the ad, the post month, the post hour when it's posted. And then the other metrics are like number of clicks and likes and all that. So in the model that I use in here is it's Bayesian linear regression. So the purpose that the advantage of using a Bayesian linear regression model is that you're able to actually sample a bunch of like the beta values in terms of linear regression. I think that's important that rather than just trying to get the value itself, try to understand how consistent these values are. And when you apply these models, just kind of make sure that your assumptions are correct. And like the Bayesian linear regression allows you to do that. If that's something you want to try, from the Bayesian point of view rather than like the linear regression point of view. So. In terms of like the model selection, right? I use the primary metric as the mean absolute error, and I'm trying to minimize that. And then, I split the data set into like a train and test, and then use backward selections to choose my features. So essentially, you have like a list of features, and if I were to take one feature away from the model, how would that affect the model, right? And as previously mentioned, the model allows you to generate like a bunch of beta values. So in this case, I was able to generate 1,000 sets of beta values, and that's, like I said, that's one of the advantages of like a Bayesian approach. From each of those sets, I'm able to use it on a test set, right? And then calculate the mean absolute error for each of those sets. So essentially, at the end of it, I have like 1,000 sets of 1,000 values for the mean absolute errors, and conduct and build out like the distribution for it. And the way I select the features, like, right? So if I were to include the month feature, which is in the blue over there on the left, you see that the distribution of the mean absolute error is shifted to the left. That's something that I want, right? You want to minimize that absolute error. So, yeah, so that's like a feature I would include, and then the other feature is the category feature, which, if I were to include it or exclude it, it doesn't really matter based on for the distribution of mean absolute error. And that's like an advantage, like I said, from the Bayesian models, that you're able to actually run these, create these distribution that the other model won't provide for you. Yeah, so this is some of the results. I ended up just using page total likes, paid, post months, and type. I found those are very strong indicators for the metric that I was going for. And the next two slides is going to talk about like how you actually go about checking your models, right? I think that's important for any machine learning projects. Like how well does the model fit the case that you're trying to achieve? So in this case, all right. So like I said before, since I have a sample of these beta values, I'm actually able to generate a distribution for like the lower tail. So yeah, I was able to capture like the distribution of the 2% and then compare it to the observed value and see how that captures, how well that captures it. And you can see that this captured the lower tail fairly well, and it also captured the upper tail fairly well. So like that's something that like a Bayesian model is able to do for you. And this is an example of like the beta distribution for one of the features that I use. Yeah, so like I said, when you're able to like display like a distribution, it gives you like a better picture of what that value is rather than just taking the mean, right? So when you plug into like a linear regression package, it usually just spits back a mean. But from this method, you actually see like how like does it have a high variance and whatnot. So I think it's a good check that you could do as well. But yeah, but that's pretty much it. I just wanted to share like a Bayesian approach to one of like a common model that everybody uses. Yeah. That's all.